It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to Unit 8, in which we switch gears from algebra and start playing around with probability. So this first lesson is kind of a quick recap of probability that we learned in middle school, and then we'll get into some newer, more advanced probability ideas throughout this unit. So a big focus on this lesson is going to be on notation that I'm going to be using throughout this unit. So a fair six-sided die is rolled. What is the probability of rolling a 3? So I want to know, what is the probability of rolling a 3? This is the notation we're going to use. Probability, the parentheses mean of rolling a 3. Well, on a die, there's 6 sides, and one of them has 3 dots on it, so the probability is 1/6. A fair coin is flipped. What is the probability of getting a heads? So the probability of flipping heads, the probability of heads is, well, hopefully you realize that's 1/2. So consider an experiment where I'm rolling the die and then flipping the coin. What's my sample space for this experiment? So a sample space is all the outcomes. What outcomes can I have during this experiment here? So I'm going to roll the die and flip a coin. So I could get heads and a 1, or tails and a 1, or heads and a 2, tails and a 2, heads 3, tails 3. I'm going through all possible outcomes of these two events occurring together. What are all the different outcomes that could occur? And notice there's 12 of them. There's 12 different outcomes that can occur here. So this here is called my sample space because it represents all the events. So consider the event rolling an even and flipping a heads. So I want the probability of even and heads. Probability of even and heads. So here we go. I need to be both even and flip a heads. So I'm only looking at this top row here because those are the heads. And I'm only allowed to pick the even numbers. So there were 3 out of 12 outcomes. I found the ones that had heads and had an even number, which is 1/4, which is also 0.25, which is also 25%. I like sticking with fractions when I deal with probability, but know that we can use decimals and percentages. Those are 3 different ways we can represent a probability. Consider the event of rolling an even or flipping a heads. So notice I'm changing the word on you here. I'm changing that conjunction there to or, which makes a big difference. And or in mathematics is inclusive. That means at least one has to be true. Both of them could happen, even or heads. I can get an even and a heads, and that's okay. It's not an exclusive or where you get one or the other. It's an inclusive or saying I just need one of them to happen, and that's enough. So what's the probability of even or rolling or flipping a heads? So I have to be even or I have to be heads. This guy's even, this guy's even. This guy's even, this guy's even, even. Or if I've got a heads, I'm already happy. So notice that it happens 9 out of the 12 outcomes. 9 out of the 12 outcomes, which is 3/4, which is 0.75, which happens to equal 75%. Now, which of these is more likely? The closer you are to 1 or 100%, the more likely the event is. A 25% chance event could happen, but it's not as likely as a 75% chance event, which I would assume most likely will happen. It might not, but it most likely will. So the spinner shown has 3 equal sectors, numbered 1, 2, 3. What is the probability of spinning a 3? What's the probability of me here landing on a 3? Well, 1 out of 3. We're going to be looking at not probabilities a lot. What's the probability of not getting a 3? Well, this happens 1 out of 3 times, so what's left over? 2 out of 3. There's 2 options out of the 3 that would land on not being a 3. What's the probability of me spinning a 4? 0. A probability of 0 means something will never happen. If I have a probability of something being 0, that means it will never occur. What's the probability of spinning an integer, of spinning a number? Well, that's 3 out of 3, which is 1. If I have a probability of 1, that means the event will always occur. I will always land on a number, 1, 2, or 3. The event will always occur. I know someone right now is saying, well, you can land on the line between them. I'm going to land on one of them. The event will always occur is a probability of 1 or 100%. If something has a probability of 1, it always occurs. And notice your answer for a probability question is always between 0 and 1. You should never have a probability of 10 or of 72 or -3. Those aren't probabilities. Now, if those were percentages, 73% is okay. But the decimal should always be between 0 and 1 or 0 and 100%, depending on whether you're working with decimals or percentages. Create a sample space for rolling a fair die and the spinner above. So I'm rolling a die and then spinning the spinner. So I can roll a 1, spin a 1. Roll a 1, spin a 2. Roll a 1. So I'm rolling, then spinning. Roll, spin, roll, spin, roll, spin. Now remember, when I roll a die have 6 sides, so I have to do this all the way up until 6. So I'm just going through all the possible outcomes in a methodical way. First, I'm going through what happens if I roll a 1? I could spin a 1, 2, or 3. If I roll a 2, I could spin a 1, 2, or 3. I'm going through all the different outcomes in an organized way. So let's find a probability here. What is the probability of rolling a perfect square? Well, perfect squares are 1, 4, 9, 16. So roll a 1 or 4, roll a perfect square. Or, so that's an at least 1. I need something to be true, the first part or the second part. Or spin an odd. So I need to roll a perfect square or spin an odd. So let's go through and roll a perfect square first. Rolling is the first number. Those are all perfect squares, and those are all rolling perfect squares. Or, so forget about the first thing, I need to spin an odd. That's spinning an odd, and that's spinning an odd. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of the 18 outcomes, which is also 7/9, which I could get a percent for, but I like fractions. Fractions are nice. So I'm rolling the perfect square. That's the first number. Had to be a 1 or 4. Or I had to spin an odd, which is the first row and the third row. I'll skip that last one there because you guys don't remember what prime numbers are. We'll do this one and then we'll be done with this lesson. This is a quick lesson here. So a bag contains 6 cards. 4 are blue, labeled A, B, C. So I've got A, B, C, D. And 2 are labeled red, E, F. Then I also have that spinner with 3 sectors. So I'm also spinning that guy there. Create a sample space for the pulling of a card and then spinning the spinner. So I could get A1, A2, A3, or B1, B2, B3. I'm just going through all the possible outcomes that can occur of me picking one of these letters and then spinning the spinner. Switch to red now, E1, E2, E3, F1, F2, F3. So I have 18 different outcomes from this event. If I pick one of these letters and spin the spinner, there's 18 possible outcomes. So is the probability of spinning a 2 affected by first pulling a blue card? Well, what's the probability of spinning a 2 without just spinning a 2? What's the probability of me spinning a 2? 1 out of 3. What's the probability of me getting a 2 knowing I pulled a blue card? Well, Me pulling the card has nothing to do with the spinner. Pulling a card doesn't affect the spinner, doesn't affect the outcome of the spinner. It's common sense. I picked a card. Why is that going to change the probability of me getting the spinner here? It doesn't affect the outcome at all. What's the probability of pulling a red card and a blue card? Well, if I reach in and pick a card, can I ever pull both? The probability of red and blue, I like that I'm using purple here, is 0. It never happens. You only pick one card. One card is pulled. What's the probability of pulling a red card or a blue card? So I'm just changing one word here from and to or. What's the probability of me getting a red or a blue card when I do this? Well, it's 100%. It always happens. This event always occurs. I will always get a red or a blue card. This event always occurs. I got two probabilities here. What is the probability of pulling a blue, and is the connector there, and an odd? So I need blue and odd. So I'm only looking at the blue ones, and I need odd numbers, odd numbers. 1, 2, 3, 4, 5, 6, 7, 8. Out of how many possible outcomes were there? There's 18 possible outcomes. So this probability is a 4/9, a little less than half. This happens about less than half the time. It's pretty close to half, but less than half the time. I'm going to change one word, and that's going to greatly change the probability. What is the probability of blue or odd? So if I'm blue, I'm good. If I'm odd, I'm good. So let's go through and look at this now. I want blue. If I got blue, I'm good. Or I'm also happy if I get odd things. So I'm going to stick those guys into my success outcomes as well. So there's 12, 13, 14, 15, 16. 16 out of 18 times this happens, which is 8 out of 9. This is a very likely outcome. It might not happen, but it's a very likely outcome compared to 4 ninths. It's much more likely than 4 ninths occurring. So overall, we're going to be looking at ands and ors and knowing the basics of these probabilities, that it's how many out of the total amount of outcomes is what is a huge idea when it comes to these probability questions we're going to be tackling. I'll see you in the next video.